Hello everyone, welcome to the channel. In previous video, I have covered what is a multitasking, what is a multi-processing, multi-threading, as well as the purpose of multi-threading, uses, advantages and disadvantages of multi-threading. And in this video, we will discuss what a thread is, why thread are important, and their significance in both real life and technical scenarios, so that you can clearly understand the concept. Additionally, we will focus on some key points to remember about threads. Okay, so let's begin. So first, let's understand what a thread is with real life scenario. For that, let's take the example of bank. We all know about bank, and to run a single bank, many employees are working there, such as branch manager, whose task is to manage the staff. Then there is the cashier, whose task is to process customer transactions, such as deposits, withdrawals, and transfers. And another employee is the loan officer, whose task is to approve loans and all related tasks. Additionally, there is the financial advisor, whose task is to provide financial services to the customers. And each employee has their own resources such as desk and PC. And some resources are in shared like Wi-Fi and other services. That means Wi-Fi and other services bank provide them to use commonly. Moreover, all employees are independent in their work, meaning that if one employee is absent, then it doesn't affect the other employees or bank doesn't remain closed. This means that even if one employee is absent, the other employees can still perform their task effectively. So basically, point is to run a single bank, all employees perform their tasks independently and effectively using their own resources and shared resources. Now let's consider here the bank is a program or a process, and all the employees are threads: thread 1, thread 2, thread 3, and thread 4. And these threads are performing their tasks to execute a single program. And as I said in the bank example, every employee has their own resources and share resources, right? Similarly, Java threads also have their own resources such as thread ID, program counter, stack, and register. All the threads have their own resources and some shared resources such as memory and data. This means that all threads use the memory and data of their own process in common. Moreover, as I mentioned earlier, all employees in the bank example perform their task independently. Similarly, threads are also independent of each other, meaning that if one thread is a block for IO operation or temporarily stop, then the other threads can still perform their task effectively without any interruption. Therefore, it's considered that all threads have their separate path of execution because they have their own resources and therefore they are independent of each other. That's why it's said that each thread has an independent flow of execution. Now let's understand it technically. For that, let's take an example of online shopping. Nowadays, online shopping has become more popular and everyone can buy products online easily. In online shopping, when user requests to search for a particular product, then a new thread is created, let's say thread 1, and the JVM requests the operating system to allocate resources to that thread, such as thread ID, program counter, stack, and register. And at the same time, if another user requests to order a particular product, then the another thread is created, let's say thread 2, and OS allocate resources to that thread separately. And the thread 2 task is to handle that another user request. Similarly, at the same time, if another user requests to pay an amount, Then again, a new thread is created, and let's say it's a thread 3 with its own resources allocated by the OS. And thread 3 task is only to handle the payment process. So here if we notice, thread 1 is performing its task using its own resources. Similarly, thread 2 and thread 3 are also performing their task simultaneously using their own resources. Basically, all threads are performing their own task to accomplish the online shopping program. But if for some reason thread 2 is blocked or temporarily stopped, then the other threads, that is thread 1 and thread 3, can still run effectively without any interruption. That means searching and payment process is still working even if thread 2 task, that is ordering product, is temporarily stopped. And it's possible because each thread has its own resources and is not dependent on other threads for its execution. They have their separate path of execution, or we can say they have their own independent flow of execution. This means that threads have the ability to execute independently. Therefore, it's considered that a thread is an independent flow of execution. So the definition of Java thread will be: a Java thread is a unit of a program or a part of a program that has an independent flow of execution in a program, allowing a program to perform multiple tasks concurrently or simultaneously. Clear? And another definition of thread is that it's a lightweight process. And I will explain why a thread is called as lightweight process further in this video. So just keep watching till end. Okay? So up to this point, I hope you understand what a thread is. Now let's understand why thread is important. So for that, first let's understand what was the scenario before Java thread. This means what challenges did developer face before the introduction of Java threads. And by exploring this scenario, you will gain a clear understanding of the importance of threads. Okay? So to understand it, let's take the example of web browser. So today everyone uses web browser for many purposes, such as to search data, to download data and all, right? And when we open a web browser, then inside a web browser we can open multiple tabs or web pages, right? Now let's imagine if we open more than 50 web pages at a time, and inside a single web page many tasks are also running, such as loading images, loading text, loading videos, loading another links and all. That means every single web page also has its own multiple tasks, or we can say every web page has its own resources to load, right? So basically, to fetch more than 50 web pages at a time, as well as to fetch each web page resources at a time, was a big challenge for web browsers developer. They had a question how to handle all these tasks at a time. Then developers decided to execute each web page as a separate process. That means if there were more than 50 web pages open, there would be more than 50 processes running under a single process. That means they start developing web browser in such a way that a web browser is a single process, and under single process multiple processes are running. They start designing such type of web browser. After that, they came to know if user open a web page, then for each web page new process will start. Now think, if single user open more than 50 web pages at a time, then there more than 50 processes are running at a time, and it may leads memory issue because processes are heavyweight, because each process has its own memory stack and resources, as well as creating a new process is more expensive because when a process is created, the operating system needs to allocate new memory to it, as well as communication between processes is also complex. And in other hand, if we think, terminating a process is also costly because when a process is terminated, the operating system needs to reclaim the memory and resources allocated to that process. So after studying process-based analogy, developers understand that this process-based approach might be costly and can create complications and might create memory issue also. And as a result, it can affect on performance of a program. So instead of using process, they start using thread, and they create multiple threads for multiple tasks running inside web browser. After using threads, web browsers start working smoothly and faster without any interruption. Because thread is lightweight as compared to process, and they are lightweight because threads use or share the memory space and the resources of its own process, and therefore there is no need to allocate separate memory and resources to the threads. They use their own process memory and resources. Therefore operating system doesn't need to allocate separate memory space for all threads, which means each thread doesn't require its own separate memory allocation. And due to this, memory being used effectively as well as less memory will use. So basically, thread help to reduce memory uses. And another point is creating and terminating threads are also relatively lightweight, as well as threads take less time to terminate as compared to process. So basically, thread is lightweight as compared to process, and therefore thread is also called as lightweight process. And it implies that processes are heavier than threads, and therefore instead of executing multiple processes at a time, it's better to execute multiple threads of a same process at a time. It will execute faster than process, and due to this program will execute faster and overall performance of a program will definitely increase. So basically, threads help to improve performance of a program. Additionally, some advantages of threads are: threads help to enhance responsiveness and scalability of a program, as well as threads help to improve system resource utilization. All these advantages I have already explained in the previous video in detail, especially in the video of multi-threading advantages and disadvantages. You can watch it out. I will provide link of it in the description of this video. And multi-threading is completely based on threads, right? Therefore, all the multi-threading advantages are applicable for threads also. And hence, you can write all those same advantages of multi-threading for threads also. Okay. Now let's understand some key points about thread. So always keep in mind that a thread is the smallest unit or a part of a program. A thread has its own resources such as thread ID, stack, register, and program counter, while some resources like memory space and data are in shared. This means that threads share memory space and data from their own process. Okay, as well as threads have their own independent path of execution or flow of execution because they have the ability to execute independently. Moreover, a thread is also referred to a lightweight process, and I have already explained why it's called lightweight process. Okay. Additionally, thread help to enhance the responsiveness and scalability of a program. They also help to reduce memory uses since they don't require their own separate memory allocation because they use their own process memory that already we have discussed. Furthermore, threads help to increase system resource utilization also. That's it. So I hope you now understand why threads are important. In this video, I have covered what a thread is and its importance. Additionally, I have covered some key points about threads that you should remember. That's all for now. I will stop here. In the next video, I will explain how to create a thread and its life cycle. Until then, keep learning, keep growing, and thank you so much for watching.